typically, if we're going to graph a linear equation, we like to see it in that slope-intercept form, right? And what is slope-intercept form? All right. And what does M tell us? What is M? The slope. Very good. And slope is telling us rise over run, right? How much up and over we would go to find our points. Okay, so slope is rise over run. And if they didn't give you the slope, but they gave you a couple points, you can find the slope, right? Because it's just change in y over change in x. So I'll write that down over here as well. Change in y over change in x. Typically, it's just the formula y2 minus y1 over x2 minus x1, right? Okay, so M is the slope. What is B? The y-intercept, right? Which typically tells us where we will intersect that y-axis, right? Okay. So our absolute value equation is going to have some similarities and some differences. We still need something like a slope, right? So we know how much up and over to go between our points. But we also know that this isn't just going to be a diagonal line, right? Okay, so the vertex form for our absolute value equations is y equals, or a lot of times they'll use function notation, so they'll say f of x equals a times the absolute value of b times x minus h, close the absolute value, and then on the end of the equation you'll have plus k. You probably recognize h and k from when you have graphed your quadratics or your parabolas in the past, right? They mean the same thing here. Those are what shift you left and right and up and down, okay? All right, so like we said, we still need some sort of a slope to tell us how far apart to make the points, right? Here, instead of just having your M tell you your slope, you have two values that you have to put together in this equation to figure out what your slope would be, okay? So your slope is going to be made up of your A and B values. So your A is kind of like the part from your equation up above that was change in y. So this is the change in y part of your slope. And B is going to be kind of like your change in x part. So I am going to have to put those two together to figure out what my slope is. When I say put them together, it's kind of like up here, right? We put them into a fraction, right, to come up with that slope. Okay, so the fraction that we would put these values into in order to find the slope would be A over the absolute value of 1 over B. Okay, so that would be how we find our slope for these type of equations, or how much up and over between our points. Okay, and then like I said, h and k you guys are probably already familiar with because you've seen those with your quadratics. Your h, the part that's inside of that parentheses with x, clearly is going to affect your x, which moves things left and right. Okay, so this is going to be the x coordinate. You can abbreviate there, of the vertex. And your k, which moves things up and down, is going to be the y coordinate of your vertex. Therefore, your coordinate for your vertex should just be the coordinate point HK. Now remember, when h is inside the parentheses there with x, it really is opposite of what its true value is, right? Just like whenever we wanted to solve something, we would take the parenthesis and set it equal to 0. For example, if inside that parenthesis you had x minus 10, right? If I wanted to figure out what the value of x actually was, I would set x minus 10 equal to 0, add the 10, and then I would get x equals 10, right? So just keep that in mind. Whatever is inside the parenthesis here in the equation, when I would go put it in here, if this was a negative 3, I'd put a positive 3 here, right? Okay. All right, so keeping that information in mind, we are now going to graph the parent function. So that way we know what the idea of this graph looks like, and then we can talk about transformations. So the absolute value parent function, remember your parent function is the one with as little change made as possible, right? As basic as it gets. Okay, that would mean that your a and b must both be 1, right? We'd have a slope of 1. So we wouldn't actually have to put a or b there if they're understood ones. I'd still have my absolute value bar of x. And if I haven't shifted anywhere, h and k should both be what? Where do we always start? Yeah, 0. So I wouldn't even need to put those in the equation either. So the parent function for the absolute value is just the absolute value of x. Okay? Well, like you guys were just saying, if h and k are not there, they're understood to be 0, right? So we know that h is 0 and k is 0. And what did we say that would mean a and b were if there's nothing written there? 1. Just like in your parent function up here, your slope is an understood 1 and your b is an understood 0 for your parent function of the linear function, right? Okay, so if my vertex is hk and hk is 0, then I have a point at 0, 0, right? Okay. And then we said that our slope, right, which is made up of a and b, in this case would just be 1 over 1, right? So I would just be going up 1 and over 1 to plot this graph. All right, now something to think about, just like with your parabolas, your quadratics. Doesn't matter what number you plug in, right, for x, even if you plug in negative 10, when you square it, it becomes a positive, right? So that's why your parabola makes that U shape, because you don't get a negative out. You can put a negative in, but you won't get a negative out, right? Well, same thing here. If I put a negative into an absolute value, am I ever going to get a negative out of it? No. So I would also be going up 1 and over 1 from the vertex going the other direction. Because we shouldn't end up with any output or any y value that's negative. So our graph basically looks like a V. Okay? So now that we have the function graphed, they ask, where would you say this function is symmetrical? Where could you fold your graph in half and everything would match up? Just this point is where I would fold it? The whole y-axis, right. I would fold it along the y-axis and everything would match up. Perfect. Okay, so we would say that it is symmetric about the y-axis. Okay, and that is what we call the axis of symmetry in your graph. So you should always have somewhere where you can fold your absolute value in half and everything should match up. It should always be the same on either side of the vertex. Okay, so here, the equation of that line, your y-axis, is a vertical line, right? So remember that's x equals a number. X equals what number when we're on the y-axis? 0. So your axis of symmetry is the equation of the line x equals 0. Okay, but like we said, this was the parent function, right? So this is the one with no changes made. It hasn't been shifted left, right, up, down, none of that stuff, right? So if we are talking about a non-parent function, then your axis of symmetry, they'll always abbreviate that with AOS, axis of symmetry, is just going to be, oops, I should put that, x equals h, okay? Because it is x equals 0 here, right? And 0 was my h value. So if I shift somewhere else, it should just be wherever I've shifted to. That is my new axis of symmetry. Okay, so now let's look at graphing some non-parent absolute value functions. So on example number 1, they give us the function f of x is equal to the absolute value of x minus 3. Well, the first thing they say we should probably do is identify a, b, h, and k. Okay, well, remember, a is usually found right here, right? Right in front. And there's nothing there, so what is it understood to be? Good. And b is normally found inside the absolute value in front of x, also not there, so it must be 1. Okay, and then where do we find h? Yeah, with the x, right? Normally it's in a parentheses, but they didn't have to have one because there wasn't anything else in there. So that makes this my h, right? Now, that is x minus 3. So if I were to actually set it equal to 0 and solve, what is the h value?
3.
Positive 3. Good. All right, and then k would normally be out here on the end, so it must be what?
0.
Right. So this was our k, our h, our b, and our a. Perfect. Okay. Now remember, the formula that they gave us for finding slope is in this case, it's 1, but it's a over the absolute value of 1 over b, which is also 1, right? So if I were to plug all that in, this is what it would look like. Well, 1 over 1 is just 1. The absolute value of 1 is 1. So 1 over 1 again is truly just 1. So just like with the parent function, we're still just going up 1 and over 1, okay? All right, and then my vertex, remember my vertex is HK. So what would our vertex be here? 3, 0. Perfect. Okay. And then they also ask us to find f of 2 and f of negative 2. That's just so that we have some extra points to plot, okay? So this just means I should go and replace the letter x with the number 2, right? So in the equation, I'd have the absolute value of 2 minus 3, right, if I went and plugged that in. And 2 minus 3 is negative 1. And what's the absolute value of negative 1? 1. Okay, so we plugged in 2 for x. We got out 1. So this would mean we have the coordinate point 2, 1 on our graph. Okay, now I'm going to do the same thing plugging in negative 2. So I'm going to have negative 2 minus 3 inside that absolute value. Negative 2 minus 3 would be, right? And then the absolute value of negative 5 is, right. So this time I would have the coordinate point negative 2, positive 5 that I can add to my graph. Okay, so keeping all that in mind, let's go ahead and graph it now. So instead of starting at 0, 0, we said our vertex said we would start where? 3, 0. Okay. And we said that our slope this time is still just 1. So from the vertex, I'm going to go up 1 and over 1 in both directions to make that V shape. All right. And sure enough, if we go check, we do have the coordinate point +2, +1. That'd be this one right here, right? It's on our graph. And we also have the coordinate point -2, +5 on our graph, right? That'd be these two in red. This is 2, 1, and this is -2, 5. All right. So here's our 2, 1, and here's our -2, 5. Perfect. Okay, and they didn't ask, but where could we fold the graph in half this time? Where would be my axis of symmetry? Right. So this time my axis of symmetry is going to be the equation of the line x equals 3. Good. Okay. All right, let's do another one together. Number 2, what's my A value? 1. What's my B value? 1. What's my H value? -2. Remember when it's inside of here, guys, it's like being in a parenthesis. So we set it equals solve. So it's actually -2. And then what's my K? 0, because there's nothing out there. Good. Okay. And then again for slope, remember we write that as A over the absolute value of 1 over B. So really it's just the 1 over the absolute value of 1 over 1, which simplifies again down to just 1. All right, so this time, where is our vertex? Good. And then we need to make sure that we know these two coordinate points so we can double check them on our graph. So I'll have the absolute value of 2 plus 2, which is 4. And then also the absolute value of -2 plus 2, which would be 0. Right. So remember, this is where the letter X normally is. So that was our X value. So we have the coordinate point 2, 4. And then from the other one, we got the coordinate point -2, 0, right? Okay. So my vertex tells me where to start. So I'm going to go plot my vertex, which we said was at -2, 0. And then my slope tells me I'm going to go up and over how much? Right. In both directions. All right, and then let's verify those coordinate points. So we said we should have one at +2, +4, which we do right there. There's 2, 4. And we said we also would have one at -2, 0, which we did. That one was our vertex, right? Okay, and then last but not least, where would you guys say that the axis of symmetry is this time? Very good. All right. All right, flip it over onto the back. On number 3, what would you guys say that the A value is? -1. Good. And B? 1. And H? 4. And what's K? 2. All right, so remember for our slope, it's A, which we said was -1, over the absolute value of 1 over B, which was 1, right? Okay, so this part in the denominator simplifies to just what? 1. So really I have negative 1 over 1. So my slope, right, or how much up and over I'll go is going to be negative 1. Okay? And then my vertex would be the coordinate point 4, 2. And then we're going to just verify a couple of extra points that should be on our graph. So remember, these are what we are plugging in for x. So I'm going to have negative times the absolute value of 2 minus 4 inside that absolute value plus 2. And remember, we treat the absolute value kind of like parentheses, right? So we simplify inside of there first. 2 minus 4 would be negative 2. Okay, but it is inside the absolute value. What's the absolute value of negative 2? 2. So I get to pull out a 2. But don't forget, there was a negative in front, right? And then we have a plus 2 on the end. So then what would this equal? 0. So we would have the coordinate point 2, 0 on our graph somewhere. Okay, now we're going to do the same thing with negative 2. Okay, so inside the absolute value, we've got negative 2 minus 4, which would be negative 6. But the absolute value of negative 6 is 6. So I'm actually just going to take out a 6, remembering that there's a negative in front and plus 2 on the end. What's that going to give us? Negative 4. So we also would have the coordinate point negative 2, negative 4 somewhere on our graph. All right. So first thing we always do is plot the vertex. You guys said our vertex was at 4, 2. Okay. Okay. And we said our slope was what this time? Negative 1. So instead of going up 1 and over 1, we should be going down 1 and over 1. Good. All right. And then those 2 points that we said should be on there would be at 2, 0, which we do have one right there, and at negative 2, negative 4, which we do have another right there. All right, and where would you guys say that the axis of symmetry is for this one? Where is it? Yeah, good. All right, you guys try number 4, and then we'll share what we come up with. Did you guys all turn in 2.2? Okay. Yeah, it's in the folder over there. Okay.
Wait, we all did.
Yeah.
Let's go. Let's go. Get started. Get started.
All right, so let's talk about what you guys got on number 4. What did we say our A value was? -1. And what did we say B was? 1. And H? -3. And K? -1. Okay. So then when we went to find our slope, it would look something like this. So we said our slope simplifies down to -1. All right. And where did we say our vertex was located? Okay. And then we needed to substitute in 2 and -2 to find some additional points, right? When we substituted in 2, what did we get as our coordinate point? 2, -6. And when we subbed in -2? Good. All right, so then it was time to graph it. And which point do we plot first? Right, that vertex. And then from the vertex, where'd we go? Okay. And then we verified that our 2 extra points we had were on there, which were at 2, -6, which we did have one there, and at -2, -2, which again we did have one there. Good. And where did you guys say that our axis of symmetry was for this one? -3. Good. Okay. So now that we've graphed a few of them, it's definitely safe to say that they're always going to have that axis of symmetry, right? They should always have somewhere we could fold them in half and match up. So we can say that absolute value graphs are symmetrical. And they are always symmetrical on what line? The value of h, right? So x equals h is where we can always fold them in half, okay? That being said, for example here, we had these 2 points, right? If you don't want to have to plot every single point, down 1 over 1, down 1 over 1, what we could do is say, okay, I know this point's on there. I know this point's on here. And if this graph is symmetrical, I automatically know it should have a matching point directly across from it, right? So that way we're not having to plot every single point, right? We can just plot a couple on one side, a couple on the other side, connect them and draw our lines. Does that make sense? Okay. So we will go over 5 and 6 tomorrow, okay? And we're going to do the practicing class. And then, like I said, I'm also going to give you test review tomorrow. And then we can review Monday, test Tuesday, okay?